the internet connect us. There we are, we're connected. We go back to the PowerPoint. So the purpose of this slide is to show you how the diaphragm is below the lung cavity, and based upon the ribs and the sternum, we're going to have the diaphragm, when it contracts, is going to make the lung cavity bigger. The pressure will be down, and air will rush into the lungs. So if you're at rest, your diaphragm is relaxed and has sort of a U shape, backward U shape. The mediastinum is the cavity for the heart. So you have the diaphragm, which is the primary muscle of respiration. And then for uh, other muscles, external intercostals, and so on, pectoralis major, minor rather, these other muscles are here when you have to have very forceful breathing for very, very strong inspiration, inhalation, and very, very strong exhalation. So notice when the lung is at rest, the external pressure of the air equals the pressure in the lungs. As the lung cavity gets bigger, as the volume increases, the pressure outside the lungs is greater, so air is going to flow in. So notice the lungs are attached to the visceral pleura, so that helps the lungs uh, expand because they're attached and they're very elastic. But when the diaphragm contracts, the lung cavities are going to increase and in size and volume, so that as the volume of the lungs go up, the pressure outside in the outside air is greater than the pressure in the lungs. When you exhale in the diaphragm muscle moves back to its relaxed position, then now the outside pressure uh, is less than the pressure in the lungs, so you exhale. This is the total volume of the lungs, 6,000 milliliters. So tidal volume is normal breathing. When you take a deep, deep breath, you can really increase the movement of air into the lungs. The expiratory reserve volume is when you breathe out very forcefully, you can get down to around 1,200 milliliters. Uh, this residual volume is always in your lungs, and sad to say, the only time that disappears is when you pass away. So the lung capacity is up to 6,000. Uh, 500 is the tidal volume. You can take an enormous amount of air in with strong inspiration. You can expel a large amount of air with when you breathe out forcefully. The vital capacity is the total of the inspiratory reserve volume and the expiratory reserve volume. So when I go get a lung test because my lungs are damaged, they measure all these various uh, volumes and they can get an idea how my lungs are doing. I do have problems with breathing, and it's done. Okay, so the whole purpose of the lungs is to bring in oxygen and to get rid of CO2. So there's a very, very thin line between the blood vessels and the alveoli. Notice the pressures. Oxygen pressure is at 100 and CO2 is around 40. External respiration means the exchange of oxygen and CO2 in the lungs. And then internal respiration is the release of oxygen to tissues and to get rid of CO2. So notice that the oxygen pressure is going down significantly after the oxygen moves into the tissues, and CO2 is higher, so that the pressure of CO2 here indicates CO2 is coming into the uh, veins, and it gets a little higher than 40. So what are the gases that are in air? I'm not going to ask much about this. We all know that oxygen is very important. Carbon dioxide, there's water vapor, and we breathe in nitrogen. The, the, the air is 79% nitrogen. We don't use that. It's breathed in and out, but we'll pick up oxygen from the lung sacs into our blood, and we'll get rid of CO2 in from the lung sacs to the blood vessels. And there's usually always water vapor in your expired and uh, and inhaled air. Okay, this is the fine chemical process. So CO2 is transported in the blood. Most of the CO2 diffuses into the red blood cell, 7% dissolves in the plasma, 23% binds to hemoglobin, forming carboamino hemoglobin, and then the 70% is converted. CO2 plus water leads to carbonic acid, and the enzyme that converts that very quickly. The bicarbonate is moved into the uh, plasma, and the H plus is uh, buffered by hemoglobin. But because of this negative charge of bicarbonate leaving, you have what's called the chloride shift. So, important take home message of this is that most of CO2 is modified in the red blood cells to form bicarbonate, so it can be carried in the plasma. The initial reaction keeps about 7% of, of CO2 in the plasma. This carbonic anhydrase is an enzyme. It's very, very important to catalyze the reaction between water and CO2, which forms carbonic acid, which then dissociates, and bicarbonate moves into the plasma. And just the opposite reaction is it will happen in the lungs, where this CO2 will come back. This bicarbonate will come back into the red blood cells, and the reaction is reversed, and CO2 then diffuses from the blood into the alveolar sacs, and with expiration, that CO2 is moved into the air, and we get rid of excess CO2. Okay, so in quiet breathing, uh, you have inspiratory muscles, and you get breathing in. Those muscles relax, and then passive expiration occurs. So this is quiet breathing. Okay, in forced breathing, you're going to have many, many more expiratory and inspiratory muscles involved. You're going to have the breathing center, the inspiratory center controls your breathing. And so inspiration is greatly enhanced in order to pull in a lot more air during exercise and to get rid of a lot of CO2 and to accumulate oxygen when you've been exercising uh, and when you need to get a much larger volume of air pumped into your lungs, not pumped into, but pumped by the muscles somewhat. But uh, you have active expiration because other muscles are involved. Expiratory muscles are involved. Those other muscles, when muscles are used beyond the diaphragm. So, how does the brain control respiration? You have respiratory centers in the pons. You have chemoreceptors, which sense how much CO2 and oxygen is in your blood. Of course, you can make a conscious effort and control your breathing, but normally it's automatically uh, controlled by sensation of these respiratory centers and right here. the respiratory centers, and then these chemoreceptors and so on. And then we have other dorsal respiratory centers and so on, and ventral respiratory centers. And these centers, based upon their sensation of the amount of oxygen and the amount of CO2 in your blood, will change your breathing patterns. And we'll be back to if you need to eliminate a great deal of CO2 after you've been exercising very strenuously, these respiratory centers will stimulate the muscles of inspiration and expiration so that you will have much more forceful breathing both in and out. Okay, that takes care of the respiratory PowerPoint. Let's stop that. Okay, stop recording. Stop